Um, let's see. We have this binomial distribution, and we should be able to get some statistics for that. So there's a little proof in your book, and some of you will enjoy looking at it or trying to prove this for yourself. But the mean of a binomial distribution is number of trials times the probability. The standard deviation is the square root of the number of trials times the probability times 1 minus the probability. And that formula is, we don't use it very often. I mean, it's great to kind of look at our theory. But let's see if we can find the meaning of the mean of this distribution. When I'm talking about, this was problem 12, so there were 30 something, they were making 30 calls or something, I can't remember. And 70% of the people were male and 30% were female. And so the mean of that distribution, which would be 30 times the probability of success for a male, I think they want, which was 0.7, which is 21, tells me more like an expected value. So an average or expected number of successes. So that's what I use. So on average, I'll get on these phone calls, I'll get 21 successes out of 30 phone calls, and successes I think are in that problem males, whatever the context of that problem was. Can't remember at this point. Yes. N is the number of trials, so it might be the number of people that you're calling. It might be the number of times that you roll the dice. It's the number of observations. And P is the percentage of your success, your probability of success. Okay. Onward to talking about a geometric distribution. I'm done with the binomial. Geometric distributions are a little bit easier to understand, I think, than binomial distributions. It's another named random variable. This random variable does not have a set number of outcomes. It could have infinite outcomes, but it can still be a random variable. So let's think, well, to be a geometric distribution, we need to have binary options, same as on the binomial. Independence, same with the binomial. Probability of success doesn't change. Yeah, so male, female, yes, no, success, failure. Only two. These three restrictions put us into what's called Bernoulli trials. The fourth thing that we added when we did binary was a fixed number of trials. Geometric doesn't have a fixed number of trials. Geometric distributions are in situations where you're looking for the first success. In trial, and first success happening in the nth trial. Okay, we'll go with kind of a simplistic model again. Let's roll a die this time. Okay, let's say I want to get a 5. What's the probability of getting a 5? What's the probability of not getting a 5? Okay. Now for a geometric setting, I'm going to ask myself, what's the probability of not getting a 5 until the 6th roll? Okay. So if I don't want to get a 5 until the 6th roll, I need to have 5 rolls that aren't a 5. Okay. So I need 5 rolls that are not a 5, and then I need a 5 on the 6th roll, because I want to have failures of a 5 for the first 5 rolls, and then I want to get a 5. So that probability that my success is on the 6th roll is failure on the first roll, failure on the 2nd, the 3rd, the 4th, the 5th, and then when I come to the 6th, I want my 5. So that officially is 5 6 to the 5th times 1/6. Probability of rolling the die and not getting a 5 until my 6th roll turns out to be 0.067. Okay. There, of course, is this is easy to do in your calculator, but there's also a shortcut function. If I just want to use the formula for this, the probability that x is equal to n is the probability of success to not the 6th power but 5th power, so that'd be n minus 1. I'm sorry, probability of failure. I got to fail. And then I get 1 success to the 1st power. So you can throw these in your calculator. You can also use a geometric PDF, and it has just 2 arguments. And I always get mixed up which way they go. Okay, probability goes first, and then goes the number of success you want to have it on. Number of trial you want to have your success on, sorry. So I can go on the distributions, look for the geometric. Oops. Went one too far. My probability of success is 1/6, so my probability of failure is 5 6. You can put a fraction in as an argument. And I want to have my first success on the 6th toss. So I put in 6. And I don't get the number that I thought I was going to get. Oh, probability of success goes in. Excuse me. 1/6. It did the opposite for me. This one I don't find real useful, so I don't use it very often. There you go. That's the one that I got. So probability of success times the trial where you want your first success.